what happened.
Classic is a nice description, actually.
It was rough. It was like a 3-hour hair appointment. It was brutal.
One of the biggest acquisition around AI out of the 90s.
So it has been a generation since we had another great neural network architecture.
So literally get the paper, try to implement it and see.
And so we now have Rex,
Nice.
the official mascot of DBRX.
Thanks everybody for joining. So today I'm super excited to have a special guest, Jonathan. And with me is Maria. Maria is senior specialist solution architect, on ML and AI. Hey, Maria.
Hello, guys. I'm glad to be here, actually.
And we have with us our special guest, so Jonathan Frankel, who is chief scientist at Databricks within Mosaic ML.
Chief AI scientist.
Oh, sorry. Chief AI
be
scientist.
Careful. Don't make me responsible for all of Spark. I can't tell you anything about how Spark works, but I know a lot about AI.
So thank you so much for joining, Jonathan. We will spend a few minutes to discuss about Databricks, Mosaic ML, and what you are doing into this world. I was surprised because I was expecting you to see with green hairs, I understood. But now I see like something very classic. So can you tell us what happened?
Classic is a nice description, actually.
Classic is very generous. Yeah. I've heard it described as Justin Timberlake from the 1990s. No, this is what remains of the green hair that I had a couple months ago when we released DBRX, or rather, as it's now pronounced, DBRX. Like the dinosaur. And I have a little prop to go with that in a moment. But I promised the team that if they trained the best open source LLM in the world at coding, I would dye my hair green. And they were quite far off a couple of weeks out, but apparently they're motivated much more by embarrassing their boss than by money or fame or power or fortune. And so now I had to dye my hair green, and I had to bleach it first. So the dye is gone, but the blonde is still there. I've gotten it cut a couple times, so now the blonde is just left on the top. And one of these days I'll have my normal hair back, maybe by Data and AI Summit.
Now you feel the pain that we women go through, right?
It was rough. It was like a 3-hour hair appointment. It was brutal.
Before working with Databricks, you worked at Mosaic ML. So you were training LLMs for customers, and then you released, I think the first open source LLM MPT available to the public. And then Mosaic ML was acquired by Databricks last year. It was like one of the biggest acquisition around AI and LLM. Can you tell us, maybe what you did at Mosaic ML, what you are doing now? How was the acquisition? What changed?
Yeah, so I think, Mosaic ML, we were always dedicated to the idea that it's possible to make it cheap and cost-effective and efficient for anyone to train their own neural networks. Now, what neural networks people wanted to train have changed a lot over the years. It started off with, we were training ResNet 50 on ImageNet back when Mosaic ML started. And by the end, we were training, 30 billion parameter LLMs. ResNet 50, for the record, is, I think, 25 million parameters. And trains in a day on 8 GPUs, 8 A100s, maybe, a lot less than that by the time Mosaic was done. It trained in I believe, less than an hour. Whereas now we're training models that train on thousands of GPUs and run for days or weeks or months. But the mission was always the same. Can we make this cheap enough and easy enough and efficient enough that anyone can do this? Any company, any person, anybody who wants to customize their own model on their own data. We think data is kind of something unique that every individual and every company has, and they should be able to leverage it to build that into AI. Now, our strategy was always around kind of trying to find every way to make things more efficient. We cared about, fancy compilers and kernels and making the most out of the GPU. I mean, you can see some dead GPUs right above me if you really want to enjoy that. But we were also obsessed with kind of algorithmic speedups. Can we change the architecture, the data, the optimizer, all the details, change the math behind how you train neural networks to get speed up? On your average H100 or A100 today, your LLM is getting about 50% of the maximum theoretical usage of the chip. What that means is that there's not really much further to go. Even if you had perfect use of the chip, you'd only get a 2x speed up. That's not enough. We need 4x or 10x. And so we have to change how we train the models. And that was always the approach at Mosaic ML. That was the approach even during my PhD, which was kind of, where a lot of those ideas personally for me began. And we've continued that now that we've joined Databricks, except now we have 12,000 customers that we can get that out to. But you can even look at this today. DBRX, which was our latest LLM, was about 4x more efficient than the MPT models that we trained last summer. And that was 4x in less than a year through a combination of better data and data practices, which it turns out Spark and Databricks help a lot with that, and better architectures and ways of training, and just a lot of learning and maturity. So 4x in less than a year. That's something that wouldn't have physically been possible just from, getting better use of the GPU. We had to change the way we trained. And Mosaic was committed to that. Now it's at Databricks and it's here for all of our customers.
That's amazing. So all of this optimization and all of this new knowledge that we have now. So how can our customers leverage it? So what are the different options that we can provide them with?
Yeah, so whenever a customer comes and they want to do anything with Gen AI, and today that's pretty much everybody, I always tell them there are a couple important principles. Number one is, you really have to start small and work your way up. Nobody should jump in today and say, I'm going to train my own GPT-4 from scratch. And there are a lot of reasons for that. One is that, Gen AI, we're still trying to understand it. And there are certain cases where it works really, really well, and certain cases where it's not working amazingly well right now. And it's hard to know before the fact. So I always recommend to people, let's try things that are really easy and really cheap and really fast. It's all about ROI. And you should kind of climb that ladder. You should start off with things that require small investment and will get you very small returns, if any. But, let's try that first. Let's try prompting GPT-4. It's an excellent model. Let's prompt it and see what happens. Let's do RAG and see what happens. Maybe something will happen, maybe something won't. But let's see. And then maybe let's go to fine tuning. And Databricks has a fine tuning product, for prompting GPT-4 or Llama 3 or DBRX. I don't really care which model. We have an inference product in our model gateway where you can go ahead and just do this today. We have something we're going to announce that, I guess we will have announced at this point, given when we're recording at Data and AI Summit, to make it really easy to do RAG. And then from there, you can fine tune your own model. You can actually customize it on your data. Requires a little more investment in terms of time and energy and cost, but you can get a lot more out of it. And you can make it a lot more efficient to use because you can have your own little custom model. You don't have to rely on a big model. You could customize something small like Llama 3 8B. Excellent model. And see if that helps. Then you can, and we have a fine tuning product for that, which is, a great way to do that. And then we can move on to what I call continued pre-training, where you're fine tuning on lots of data. And then you can move on to curriculum learning, where you're literally replacing part of how we pre-trained a model like DBRX with pre-training on your data. We can kind of give you a model that's 90% trained and you can redo the last 10% on your data. It's kind of an in-between of fine-tuning and pre-training. We actually have an API for that, the pre-training API that's now in preview. And then you can go all the way and pre-train your own model from scratch. Now, again, you should start small and work your way up. If you try to do that last step right away, it's kind of dangerous. And again, a couple of reasons for that. First of all, we need to make sure there's our ROI. We need to make sure that it's worth it to you to do this. I don't want anybody wasting their time and energy and money unnecessarily. And those smaller steps are the right way to start building that maturity and working your way up. The second is a maturity question. I don't think many folks are ready to dive in and pre-train a GPT-4 model. And what I mean by that is you've got to have your data in a really good state. You've got to know your data incredibly well and probably bring in some additional data to kind of fill out gaps that you have. And you need to know where those gaps are. You need to know how to measure what success looks like. It would terrify me. This is my biggest fear. Someone comes to me and says, hey, Jonathan, I just trained this GPT-4 class model. It took months and months and tons of money and tons of work. Is it good? That's my biggest fear. And honestly, I think it's a legitimate fear right now. We need to have evaluations so that we can measure whether that model is good before we've trained it. In fact, you need to have trained enough smaller models that you can predict how good that big model is going to be before you ever train it and know whether you succeeded. That requires some maturity. That requires some time and energy. It's a hill that we have to climb together. And so for me, it's working your way up that ladder step by step. Different people are in different places. We're here to help you to do that. And, at the end of it, I think a lot of people should have their own custom models. But some people may be very satisfied with RAG, and that may be the right ROI. That's great. Some people may find that Gen AI just isn't ready for what they're trying to do. It can't reach the level of reliability or quality that they need. It can't work with the kind of data they have. That's okay too. We're making a lot of progress and we're doing new research every day. If it doesn't work today, it may work next year, or it may work tomorrow for that matter. But we have to start small and work our way up and be patient.
Can you give us a few examples, like a few customer example, what they did using fine-tuning or training from like a new model from scratch?
Yeah, definitely. So I don't want to speak out of turn about any of my customers, but I can give you just a few examples off the top of my head. For training from scratch, this tends to be the most popular in cases where there simply doesn't exist any model that's good at the thing that people care about. So one example is Replit, which trained these really small, really efficient code models because they wanted to offer code completion to every user, even their free users. Code completion is pretty expensive to do if you're doing it for everybody. So they had to train small, efficient models that were cheap and cost effective enough that they could do this. Another example, we have a company doing, proteomics. There's no model for proteomics in the world. You can't use Llama 3 for that. So they had to train their own model from scratch. One company, Ola, which is training the world's best model for India. The model is built to be good at, I think it's a couple dozen languages spoken in India. Because there are a lot of different languages, it's low resource data. Ola has done really hard work to collect data in those languages and has provided a model that's serving, a huge and important community in the world and is doing so better than any model in the world. So for custom pre-training, those are the scenarios that really speak to me. When it comes to fine-tuning and prompting, this is where you see dozens and dozens and dozens of scenarios. Everybody from the BBC, which is using this to, help prepare articles so that journalists can spend more time in the field and less time, doing mundane work. There are tons and tons of scenarios like this. So I'm seeing it across the board, and lots of folks are working their way up that maturity curve. And yesterday we're doing prompting, and today we're doing fine-tuning. And a lot of people who yesterday were doing fine-tuning and today are doing pre-training. So it's really exciting to just watch everyone climb that maturity curve.
So Jonathan, specifically on the fine-tuning, could you explain a little bit more, like what will fine-tuning give us specifically, right? So okay, pre-training give us a completely new model. Fine-tuning, what is the benefit of fine-tuning per se?
So fine-tuning will give you a model that knows about your data. It's not going to be a model that, only knows about your data or is really truly specialized to your domain, that kind of only speaks your language and speaks it really well. But it's a model that at least has seen your data before you prompt it. Prompting is stateless. The model will see the data, in the context, and you have to hope that the model is able to kind of reason about that data live in a way where good things will happen. And fine-tuning the model is actually, or the data is actually built into the model. And so it's a little more powerful. Now, there are trade-offs there. By training on that data, you're specializing the model for just that data. If your data gets updated frequently, that can be tricky because you have to fine-tune frequently to do that. If you have access control restrictions where certain users should only interact with certain data, fine-tuning can be tricky because it's all baked into one model. These are scenarios where RAG can be really helpful. It can keep your data up to date. It can give you access control. My best recommendation is actually do fine-tuning and RAG. It gives you the best of both worlds. The model will kind of know about your data fundamentally. It won't have to gather information about your data live in the context where it can do less with the data. It's less powerful. But you also get the benefits of constantly having new data that you can pull in via RAG. So keep in mind, these aren't mutually exclusive. You can do many of these things. You could even pre-train your own model and then fine-tune it on something more specialized to really make it focus. Now, fine-tuning is a little bit, there are trade-offs. Sometimes the model will get so specialized to the data, it will forget other things. And so there are a lot of tricks and techniques we have for kind of managing this trade-off between learning and forgetting. In fact, we just put out a paper on LoRa, which is a very popular technique for fine-tuning. And LoRa is interesting. I don't actually recommend it in all scenarios, but one thing we found it's really good at is keeping your model from forgetting. The trade-off is that it restricts how much your model can learn. So pros and cons, you have to make this trade-off for yourself, but it gives you options. It gives you a design space to work in to try to find the best trade-off for you. And I think that's the most important thing my team provides. It's just good choices that have science to back up when you should use them and when you shouldn't.
Maybe we should deep dive a little bit on DBRX, DBRX.
Yeah, actually on DBRX, if you'll give me one moment, I'll be right back. I need to show you something.
Okay. Now I'm expecting to see a full T-Rex.
So every good model needs a good mascot. There was Llama, there was Dolly, and so we now have Rex.
Nice.
The official mascot of DBRX. We have a mascot, some graphic design that will go with DBRX, and some swag that will be given out at Data and AI Summit, including, a bunch of these little Rexes. This is the cutest dinosaur I think I've ever seen. The next version of DBRX, and I think I can say there's another version coming. The code name is Velociraptor. We're leaning in very hard to this branding. Every model needs a mascot, and I think Rex is a fantastic mascot for the kinds of models we're creating. And Velociraptor is a great, mascot for, for what's to come. And, that may tell you it's going to be small, very fast, and, a little bit bloodthirsty.
Like this. From
exactly. Exactly. I did have to, got to share my little friend.
Can you tell us about what did you do to make DBRX work, like DBRX rock? Did you, what does it take to train a full model like that? How is it working?
So I think the first thing we should always start with is why. Why do you train a model like this? And I mean that because you don't train a model just for fun. It is very fun to train a model, but it's really hard. It's really expensive. It takes a lot of time and energy. So why do that? And there were a couple of reasons. The first is, part of my job here is to make sure that Databricks is the best place in the world to create your own custom Gen AI at every step of this process we talked about. I need to figure out whether we are the best place in the world to do that. And so I had to build a model. I had to build something that was bigger, I hoped, than anything our customers would do anytime soon, that would push the envelope on all of our tooling. Everything from Spark. We were working on massive data sets and used Spark to pre-process all of our data, to Mlflow for experiment tracking, to our inference service for speed, to, our actual Mosaic training. We used the same Mosaic training infrastructure we used for MPT, but with a lot of upgrades and, a lot of Databricks integration. And I wanted to see what is the end-to-end experience for training models using all of our Databricks Gen AI tools. In fact, there was actually one thing that we needed to use that wasn't native to Databricks. It was this tool called Lilac for data exploration. But you may recall that Databricks recently acquired Lilac.
Yes.
Kind of interesting. We liked it a lot. We liked it so much, we decided to buy it. So DBRX, or, DBRX, was really about testing this end-to-end pipeline, stress testing it, figuring out where we had work to do, figuring out how we could make things better and how we could make things amazing for our customers. So I think mission accomplished there. We used the full suite of Databricks tools. We used Unity Catalog for governance. We, basically everything, and had a great experience. And there were a bunch of places where we came out with new recommendations. And those recommendations are now going into production. Mlflow has been greatly upgraded for Gen AI use cases, and we're now switching our team over to completely using Mlflow because it's met that standard. Lilac is here, and we're revamping Lilac to integrate with Databricks. Spark has a bunch of new use cases and a bunch of notebooks that we've created, and we're now sharing with customers that we used for DBRX. So that was goal number one. And to do that, the model doesn't have to be perfect. The model doesn't even have to be good. We just have to have tried. Now, it was also a pretty good model, and I'm really proud of that. The other piece was that we wanted to show our customers that if they came and wanted to pre-train a model with us, they could train world-class models. This is the best model in the world that someone could come and train today with a company. That you could go to a company and say, hey, I want to train a model just like that, but with my data or my customizations. This is the best model in the world where that's ever been done, where that's a real product, not just something internal, but a legit product that somebody can go and use. And I hope we prove to all of our customers that, Databricks with Mosaic AI is still the best place in the world to do that. And, you look at this model, I said a 4x efficiency improvement over MPT. This is our next iteration of our pre-training product and our continued pre-training product and our fine-tuning product. This is now the latest stuff, and you get all those benefits if you come and train with us. I promise our customers efficiency. If I lower costs, ROI is higher for anything that a customer wants to do. And it's good for business because customers will want to do more stuff and they'll get more out of it. That's just a complete win across the board for everybody. The third was we wanted to provide something great for the open source community. I wanted to do something that was unique. Mixture of expert models were pretty unique at that time. I wanted to do something that was really powerful. It was the most powerful open source model in the world at the time of release. I wanted it to be big. It's 130 billion parameters, which looked huge at the time. And so, for all three of those reasons, we serve the community because the community helps us. We stand on the shoulders of giants in the community, and we've tried through DBRX to recognize all of the amazing work and the amazing people who helped us. We hope by giving this back, the community will have another amazing artifact and they'll be able to do great things as well. I come from that community and I want to never forget where I came from.
Wow, thanks. So this explains why it was built and why you open sourced mainly everything, right? So not only the model, but all the different components you use to train it. So
because we have no business need not to.
Yeah.
It's always a tricky thing doing research in industry where you have to balance business, and business is what pays for the research and allows you to keep doing it, and sharing that research and serving the community. I feel really lucky that we're at Databricks, where there's a commitment from the very first day the company was founded to share with the community and to make the world a better place. A belief that we can make Databricks the best place to use this technology, but we should have to win on our own merits, not because we locked you in. And so DBRX is open source. I think Databricks is the best place to work with that model and the technology underlying it. But if somebody else builds something better, that's competition, and we have to do an even better job. We have to win our customers' business every single day. And I like that a lot more than locking people into an ecosystem. We're going to build better products, and it's just going to be good for the team. But again, the other piece is we have nothing to hide. We don't make our money off of having some big secret. We make our money off of having an amazing product where you can come and customize this. So what do we have to hide? Why shouldn't we share our checkpoints and share how we built this and share, our code for training this model and our code for serving this model? What do we have to lose if we're the best product? People are still going to work with us. So I take this as a sign of confidence, but also a sign of investing in the community, because that's what will power the next version of DBRX, is great innovation from the community that we're able to put together into something, really great. And then we share that back and the community does more great work with it. And it's that cycle that I think, that's what makes the scientific world go around. We can't just take, we have to give back as well.
So you mentioned a new version of DBRX. How is it working? Like, do you keep the same architecture and just swap the version? Do you just, update the weights? Do you retrain on whatever you have? What's the secret sauce?
I can't say too much. I don't really like to tease things, so that's as much teasing as I'll give. I say this in all seriousness. First of all, you never know what you're going to get whenever you set out to train a new model. So I don't want to promise too much or promise a timeline right now, because who knows what will happen. The other is I really like to speak through my work, less so through words. So I hope that DBRX speaks for itself in terms of what we did, how we built it, what our values are, how we care about our customers and the community. And I like to let the models and let the papers and let the science speak for itself as well. So I hope the next model will speak for itself. And we'll wait for the model to do that.
Amazing. So, Jonathan, let's take you back to the data. So, any best practices that you can share on how to structure data before training a big model like DBRX?
Yeah, we learned a ton of lessons along the way. Data is really hard. One of the things I learned along the way was thank goodness for Databricks. We did the MPT data on our own using some weird collection of tools that we threw together. It was really hard. With the help of some Databricks folks, especially, Sean Owen, who I'll give a shout out to, we were able to get all of our pre-training data and all of our after-training data into Databricks within 2 weeks of joining. And then we've started moving so much faster on the data side, because we can just, as an example, we can, I think we can embed 1 trillion tokens of data for $1,000, which is insane. And we can tokenize our entire, many trillions of data that we use for pre-training in like minutes. These are things that took us days of manual work previously. So we're much more focused on the science, not on the process. And that's been huge. From a data practices perspective, I'm going to sound like a broken record, but the very first thing to think about is how you measure whether your model's good. Until you have evaluations, you have nothing. And there's no such thing as a free lunch when it comes to data. You're choosing your data for a purpose. You're training your model for a purpose. And if I told you, this is actually an exercise I love to run whenever I give a talk about DBRX. I'll run this at Data and AI Summit. I'll put up a list of kind of data sources and then ask people to take a minute and tell me how to choose that data. Should you like repeat Wikipedia a lot of times because it's a very high quality data set? Or should you use data from the web, which is, you know, probably lower quality, but more quantity? If you need to build a 1 trillion token data set, how do you kind of weigh these things? And I love giving this question, number one, because it's interesting to see people's answers. Intuition is really hard. We have best practices here. But the other is that eventually someone will ask me after a couple minutes of doing this, wait, but what is this model supposed to do? And that's exactly what I really want people to get out of this, is to realize, wait, I can't choose the data independent of the context of what I'm trying to do with the model and how I'm measuring success. If it's a code model, you'll make very different choices than if it's a model designed for Japanese. If it's a model designed to be in an ultra safe kind of factual setting versus a model for creative and storytelling purposes, you'll make very different choices. And so that's the first step. We made the choice that we wanted a model that was kind of good at general purpose work, especially good at code, but, you know, really good as a general purpose chatbot. And that affected some of the data that we chose. We then added a few other interesting best practices. It's impossible at large scales to try out all the possible different data mixes. So we tried to make very specific choices of what we explored, like code versus non-code. What is the right percentage there? Because we couldn't explore every possible combination. We looked into, like, should you upsample high quality data sets like Wikipedia or should you not? The lesson was actually high quality data sets, the model tends to learn pretty quickly anyway. So treat all tokens equally for the most part. So we did that. We learned that actually you should change your data mix late in training to focus on data sets that you think are higher quality. And the nice thing is that although it's too expensive to try out all possible data mixes at the beginning of training for the whole thing, it is possible to just try out a bunch of different data mixes for the very end of training, especially on smaller models. And so we were able to find a really amazing data mix for the end of training and use that as a way to, you know, kind of finish strong. We learned that if you're trying out small models, sometimes they aren't actually good enough to give you signal on large models. To give you one example, there's a popular coding benchmark called human eval. It has nothing to do with the actual human evaluation. That's just what they call it. I don't know why. You need a pretty big model trained on that data set before you get any signal, before your model isn't just randomly guessing. And so if you train too small of a model while exploring the amount of code, you'll end up just randomly guessing. And you won't actually get any signal. You'll just be choosing based on noise. You need a sufficiently big model to get signal there. So it's important to pay attention to that as well. So there are a lot of pitfalls and a lot of gotchas. But at the end of the day, I'm actually really proud of the data effort. And token for token, we actually ran this experiment. We retrained MPT-7B, but using our new data set instead. Otherwise, identical architecture, identical hyperparameters, identical everything. It was way better with the new data set. And then I did this cool thing where I told the team, let's try training a version of MPT-7B, but on half the data with the new data set. And it did better than the original MPT-7B, which had twice the data. That is to say, our data was 2 times better token for token than our last data set. And I think that's pretty amazing. And then when you throw in some of these other tricks that we didn't even use, this is just the raw data set, I would say we're probably closer to 4x better. If you do this kind of data set switching at the end of training and a few other things I've recommended. So just the data alone was 2x better, with additional data practices, 4x better. That's incredible in 9 months. Actually less than that, because it was closer to 6 months when we got the data set before we started training.
So then is there a rule of thumb, as in how many tokens you should have, depending how big the model you want to train will be?
So sort of. For pre-training, the rule of thumb is kind of the best way to make use of your budget is 20x the number of parameters as number of tokens. That's kind of the optimal ratio. There's this paper called Chinchilla that showed this, and we've seen it still in our experiments to this day. The paper is about 3 or 4 years old. With that said, though, there are a lot of trade-offs. Maybe you want to spend a little extra money for training, train a model that's too small, because it'll make inference faster. This is what the Llama paper did. They trained models that were far smaller than optimal. So they were being a little less efficient on training, but it paid off because they got these amazingly small models for, fine-tuning and inference that became very popular because they were so small. And we did the same thing for DBRX. The optimal ratio was 20. We actually did 80x for DBRX. And the new Llama 3 model, I believe, did closer to 1,000x for Llama 3 8B. That's very inefficient from a training compute perspective, but it's an investment. So the details matter. And the situation matters. It's always a question of how are you going to use this in ROI. This is honestly why I love getting to work with customers, and I recommend they come work with us. We understand these trade-offs really well. We've studied them really carefully because we do this every day for ourselves. And we're always happy to have that conversation about what the right trade-off is for your setting. When it comes to fine-tuning, these are much less of a challenge because the model's already mostly trained and you're just really doing a little bit on top of it. But it still comes down to a question of, if you need the model to be sufficiently fast in practice when you're doing inference, then you're going to have to train a small model and maybe train it for longer. So again, it's all about trade-offs and ROI, but I'm here to help with that, and my team is here to help with that.
Is it the same using a mixture of experts, or just going with a dense model? Like, is using a mixture of experts just a trade-off between the cost of training and the cost of inference?
It is. We'll talk about mixture of experts, I think, in a moment, because it's always good to talk a little bit about what that means and what that doesn't mean. I think people the name sounds a little bit sexier than what it is. But mixture of experts is just a different, it's a different way of structuring the network, kind of a variation of a transformer. But really, we've seen kind of the same behaviors. Mixture of experts do behave a little bit differently in some respects, but nothing that's meaningful enough that I'd really tell people to change what they're doing. I want to say a bit about what a mixture of expert model is, because I think this is important. People think of this and they say, oh, I'll have a specialized model for finance and for Japanese and for retail and what have you, and I'll somehow put them all together and make that into one super model that can combine the best of that. That's not really what it is. I don't want to deal with the technical details because I think they're actually a little bit confusing and the name is confusing. The most important part of a mixture of expert model is this. Generally, bigger models are better. They're smarter. Again, I mentioned that Llama 3 8B used a 1000x ratio of parameters versus amount of training data, and that 20 is the right thing. So they were way off from that. They were 50x off from that. Ideally, you'd train a bigger model and have a little bit less data, and that would be a better way to spend your budget. It would be more efficient. The challenge is bigger models are more expensive to serve. They're just bigger and slower. And so how do you break this trade-off? What if you have a big model, but you don't use all of the model? Every time that you ever use the model for serving or even train the model, you only use a small part of it, and the model dynamically chooses which pieces are relevant. That's a mixture of expert model. So you're decoupling the overall size, and in that sense, the smarts of the model, from how fast it is and how much it costs to use it. That's the power of a mixture of expert model. We love this because it gives new trade-offs. It improves the trade-off that you have between your training compute and your inference compute, between the smarts of the model and how efficient it is. That's the big deal of mixture of experts. The rest is just details. So don't get too confused by the name. Don't get misled by any of that. The important part is you can have your cake and eat it too. You can have a big smart model and you can have the cost of a much smaller model.
So Jonathan, can you expand a little on this? So if I have DBRX, which is a mixture of experts model, and I want to serve it, I will serve it as a whole model, no? Mm-hmm. And then on inference, different parts of the architecture are being, let's say, kicked off and to create the output for me.
Exactly. So okay. DBRX has 132 billion parameters. If you were to actually use that 132 billion parameters, it'll be about twice as slow as a 70 billion parameter model like Llama 3 70B. Or, but it only ever uses 36 billion parameters on any given input. It's actually twice as fast as Llama 3 70B. So it has double the parameters, but it's twice as fast. That's kind of, you would assume it would, be the other way around, double the parameters, twice as slow. But thanks to the mixture of experts, we're only using about half as many parameters as Llama 3 70B does. So, it gives us a really nice advantage. It's a tricky architecture to train, but I've already done the work of figuring out how to do that. And now we can just plug and play. If you come to me and you say you want a train run, cool, figured that out already. Now we can help you do it on your data.
So then in terms of memory, when you load the model, it's still a big model, but on inference time, it's much faster. And in terms of quality, I guess it's comparable or even better.
Yeah, it gives you, quality is always tricky because any model size can get to any quality for the most part if you try hard enough, kind of as a first approximation. Llama 3 8B is about as good as Llama 2 7dB, but it was a lot more expensive to train.
Yes.
So it's really about, you can cram anything into any package. DBRX was in some sense me saying, well, I've got a limited budget. Not all of us, can go and spend, billions and billions of dollars just for a fun project. Some of us, we have a business to focus on here. So I have to make the best trade-off for what I can afford and get a really good model, and what my customers will be able to take advantage of in a meaningful way. And having a mixture of experts gave me better trade-offs to make than just training a normal model. And so I could spend my budget wisely, still train a really big model, and still make it really, really fast. That's really exciting.
So and how do you benchmark that? Like, do you compute the cost of training and you compare that with the actual performance? Like, do you have a flop, like a training flop per performance output?
Yeah. We track very closely the actual flop utilization on the GPU. Because, just because you're hypothetically using a certain number of flops for the model doesn't mean you're actually getting good performance out of the GPU. So we always look at what percentage of the real GPU performance are we getting. And we try to maximize that. And then we separately look at, okay, what is the same thing for inference, basically. What flop utilization are we going to get out of the GPU? How many tokens per second are we going to get? What is the dollars per token? All those sorts of metrics. And we think about that really carefully. And we try to make the best choices there. And it's a trade-off for me. If I had 10 times the budget, maybe I would have trained a model much smaller for much longer and tried to get something even more efficient for inference. Or maybe if I had 10 times the budget, I'd actually just train something a lot better and maintain the same trade-off, or even pick a bigger model. So it's always this question of, how good does it need to be versus how fast, and how cheap does it need to be versus how much budget do we have and how should we spend that optimally? It's really tricky. It's tricky for anybody who comes along and wants to train or fine-tune their own model. That's what my team is here for. We've done our homework. We've already trained the model. We've had to think this through, and we're here to help you think it through.
Let's maybe talk about evaluation. When you train a general model like DBRX, how do you know it's working well at the end?
It's really hard to know. Evaluation is the single hardest thing in all of Gen AI right now. We have a huge suite of benchmarks. We call it the Databricks model gauntlet. It's a combination of 36 open source benchmarks, at least it was 36 last I checked, all from the community, that we've combined into various categories like reading comprehension or logical reasoning or programming, where we've also curated the benchmarks a little bit. We've said, here are the benchmarks that we think are just noise. Here are the benchmarks where we've saturated, like every model is going to do amazingly well. Those kinds of benchmarks don't contribute any meaningful signal, so we leave them out. Then we go through and we look at which benchmarks are actually good quality. Some of these benchmarks are just kind of nonsense, have a lot of wrong answers or things like that. And we measure the model on that. Now, I'm not satisfied with that. I don't think this is good enough. Nobody thinks the evaluations we have are good enough right now. So internally, we're constantly building new evaluations. And we have a bunch of in-house benchmarks that we've created for our scenarios, both from product teams that are trying to deploy these models and from my team trying to measure. For example, there are a lot of public benchmarks on text to SQL. We're not very satisfied with them. We don't think they're hard enough. We don't think they reflect real-world use cases where there are typically multiple turns of interaction with the model to try to get the right SQL and get the right output. So we're building benchmarks for that. We think function calling benchmarks that exist in practice are pretty weak. They're not hard enough, and they're not kind of reflective of real scenarios. So we're building an enterprise function calling benchmark right now internally. And everybody should be doing this. Every customer we work with should be building a benchmark to measure the thing they care about. Again, we're doing this the hard way so that our customers can do this the easy way.
Are you planning to open source that too?
So the benchmarks, it's always a tricky thing with open sourcing benchmarks. A lot of people are starting to do a thing where they open source part of the benchmark, but not the whole thing. Because once you've open sourced the benchmark, people can just train on it. They can game it. If you keep a little bit of it closed, that gives you a way to maintain kind of a clean leaderboard.
Yeah, it was always like my intuition would be that as soon as you open source any benchmark, and they will somehow get leaked and appear in the training data sets. So I'm always surprised to see all these open benchmark, because for me, like, even if you don't want it, somehow it must be super easy to get them into the training.
It can get into the training data. Just because it's in the training data doesn't mean the model memorizes it or will focus on it. It's still a small part of the training set, all things considered. And the other piece is that I think most people are acting in good faith. But yeah, it's hard. And once you have a benchmark, what is it? Goodhart's law? Like, Any metric ceases to be useful as soon as, you start, evaluating people on it. So we constantly need new benchmarks. And I think maintaining a little bit in-house and a little bit externally is a really good way to strike this balance, because we do want to give this to the community. Having to submit your model to a leaderboard is really slow.
Yeah.
I want people to move fast.
And are we tuning our benchmarks depending the type of model we're trying to optimize for?
Oh yeah. Like we're constantly thinking about should we build an independent, model for function calling or a model specific for chat or what have you? Those sorts of things. We've already, Databricks has, built independent models for text to SQL. Should these models be specialized or should they not be? And, which benchmark should we focus on? This is constantly a discussion. So it's really important to me that we always have our eyes on what's important to our customers.
So what about evaluation, but for customers? Like I'm fine-tuning my LLM, I'm fine-tuning maybe DBRX on Databricks. Can you share like the best practices around evaluation? What should you check?
So I think the evaluation is still really tricky. And I don't know if I have like a clear best practice that everybody should follow. It is somewhat bespoke. But the way that I think about this is, to the extent that you already have an existing pipeline, like a human-driven pipeline where this model is in practice and being checked, or even just a process where things are being checked, trying to leverage that pipeline and having humans review the outputs of the model is the very best way to do this. That is the gold standard. Automated evals are nice so that you can iterate, but automated evals are very finicky. If you want to have a perfect automated eval that will always give you the right answer, you typically have to go with a multiple choice question, and nothing is multiple choice in the real world. If you want to have, unstructured outputs that check automatically, you have to use another model to check them, and that's very finicky and unreliable. It works. It's not perfect, and it's good enough for a lot of scenarios, but it's still finicky and unreliable, and it's not as good as the gold standard of having humans review. So it's kind of worth thinking about that hierarchy. You need something that's fast to iterate with. Using LLM as a judge is a great way to do that. It shouldn't be the end-all be-all if you can possibly help it. So it does get tricky in these scenarios. And my team's grappling with this every day as well. We read our eval sets, the entirety of our eval sets, very carefully, because they're often surprises. We look at the outputs of the model in addition to having an LLM as a judge look at them, because sometimes the LLM as a judge is not doing what you think it's doing or behaving in a way you like. Sometimes, your model is writing correct SQL, but the SQL implementation you've chosen to use, like SQLite, doesn't support the commands. And so you're erroneously getting error messages. We've seen that before. So there's a lot of it is still a very hands-on process. The way that I think of deep learning right now is, it used to be that we had to spend a ton of our time building software and then a little bit of our time writing unit tests. With deep learning, in some sense, the software just comes into being on its own. You just push a button, give it some data, hand it some GPUs, and the software builds itself. So most of the work is going to be in evaluation, measurement, and testing. And that's the price we pay for having this amazing technology that builds our software for us.
So then we use LLM as a judge and always human in the loop then as best practice, at least for now.
Yeah, to the best extent that you can. And I know it's easier said than done for me to say just use a bunch of humans. If only we could use a bunch of humans. This is why I say, when you're an enterprise, you're probably building a model to augment an existing process. To the extent that you can instrument that process and add, exploit that process as evaluation, that can be really powerful. That's a great way to do this without incurring a lot of time and energy. It's much more difficult if you don't have that existing process. That's where LLM as a judge can come in handy. But again, there are trade-offs to both of these. So easy for me to say, just have humans do it. Much harder in practice, and I totally respect that.
So you mean like if you are, whatever the easiest use case, like a bot that replies to you with, I don't know, a RAG use case, for example, when you show the answer to the customer, then, or to whoever is viewing that, then they can judge it as a positive or negative or good answer or bad answer. Like crowdsource the evaluation to anyone who could use this application mainly.
Yeah, the way that I would think about it is that, let's suppose you have a process where your model is trying to do some kind of classification. Let's say it's trying to put something into one of 1,000 categories. And right now a human would do all of this, but you want your model to take care of the easy scenarios. And, have humans focus on the hard scenarios. That's better for everybody. You should still once you deploy that model initially, maybe you don't even deploy the model. You kind of use the model, keep track of what the model is predicting, and test it against what the humans are predicting. Maybe once you've deployed the model, you still have the humans check, 1 out of every 10 model predictions and, see what the human says. That's a great way to find out whether your model is really behaving the way you want it to. You shouldn't just, release it into practice and hope for the best.
Shadow the humans then.
Exactly.
Nice.
Because you're trying to make humans' lives easier with these models. But, the flip side is that the models actually have to be good and reliable.
Amazing. So in terms of future of Gen AI and what is coming, in my view, in my mind, what I see coming is a lot of agents and a lot of multimodal stuff. So what is your view on that, Jonathan?
So if you see that coming, you're smarter than me. I always say during these podcasts that I try not to predict the future.
Okay.
The present is complicated enough. And I think if anyone were trying to predict the future over the past several years, they would have been completely wrong. So I think it's better to accept that we're not certain. Accept that, we don't know what's coming. Prepare for anything. And preparing for anything means getting our data in order, figuring out how to measure. Those are things that will always stand the test of time. The rest, the technologies will change. What we want to do with them will change. The ideas will change. But data, good evaluation, and good processes to integrate Gen AI into, those will always be valuable. And so that's really kind of my prediction of the future. The rest we'll have to find out.
Nicely said. With me, the data part is really sticking because as you start tuning and training models, you start seeing that if your data is not in the right place, if your quality is not good, then again, trust in, trust out, right? The usual ML problem. So it's very interesting to see it coming back and all the time.
Yeah, on the data front, I often get asked, like, in the age of Gen AI, do you even need to clean your data or structure it? Can you just throw it all into the model? And the answer is yes, you need to. The more structure you can give, the better. If your data is structured in a SQL database, you can have a model write SQL. It works much better than just handing all the data to the model in the context and having the model flatten it. So, the structure, quality, cleaning, all of that stuff is more important than ever in a Gen AI world. And I just, who knows what the future will bring? The best we can do is to be prepared.
All right. Anything else? Oh, I have a last question. So you said that, but I saw you have a bet on is attention all you need. Can you comment on that? What happened?
Yeah, so this is my dear friend Sasha Rush at Cornell Tech and Hugging Face. He, asked on Twitter a couple of years ago, anybody willing to bet with me that, transformers and networks with self-attention will still be the best way to train for natural language processing in a few years? And I was dumb enough to say yes. And Sasha, being the wonderful person that he is, literally created a website for this bet. I believe we bet, a couple shares of Mosaic ML against a couple shares of Hugging Face, both of which have become much more valuable since then. So, hopefully one of us will be making a good donation to charity at some point in a few years. But I bet that attention will still be the de facto way of doing this, or the default way. And my reasoning is pretty simple. I love to ask this question. I'll ask both of you. What were we using for NLP prior to the transformer and self-attention?
Bag of words.
Good guess. What's the kind of neural network model architecture?
Behind bag of words.
Or just kind of in general, prior to transformers. What was our pre-transformer?
Well, it was just embeddings and things like gloves, I would say.
You're going back to 2015. I'm going back to the 90s.
To the 90s.
So it was a recurrent neural network, or an LSTM.
Oh, yes. Okay.
Those are the default architecture prior to a transformer. And now I'd like to ask, which is older, me or an LSTM?
I would never guess an age of a person.
Tell me, which one? Me or an LSTM? I'm not asking you to guess the age, just, which one's older?
Probably you then.
Yeah. Are you going to guess me or the LSTM?
I'm going to say you.
So I'm barely older. Barely. It has been a generation since we had another great neural network architecture. The convolutional neural network for computer vision is still, in my view, the best way to do computer vision networks. The vision transformer has still not surpassed it. And the convolutional neural network is older than me. We get new neural network architectures very rarely. It's really hard to come up with them. It takes a lot of work and a lot of people failing, and someone gets lucky. So I'm willing to take this side of the bet, because my bet is took us a generation to get a new architecture for NLP. It's been more than a generation, and we still haven't gotten a new architecture for computer vision. I'm willing to bet that transformers are going to be here to stay for a long time.
Very interesting. And then, since we are talking about convolutional neural networks, so since we have DBRX, are we going to plan to release any other model, like text to video, text to audio?
Again, I don't like to talk about things before they're out. If this is going to go out after Data and AI Summit, I can say that I'm very excited that Databricks has announced our first text-to-image model that is available for our customers, trained in cooperation with Shutterstock, which is, the leading stock photo company in the world. They have a data set where, all the data is, licensed in, a careful way from content creators. Content creators actually get compensated every time this model is used on Databricks or on Shutterstock.
Wow. Nice.
We've been working on this for about a year. It's been a huge collaboration with our friends at Shutterstock. I can't be more excited that this is, the first of many things to come out of that collaboration. We hope this gives enterprise customers a lot of confidence in a text-image model. I know there's been a lot of kind of concern and nervousness around working with these models, given, what data they might have been trained on and where it came from. This is something that I feel very comfortable standing behind as, something I trust, something that I hope enterprises can trust. So I'm really excited that we've now announced this and it's available to our customers.
Beautiful. And last question from my side. So how is the day-to-day life in Mosaic ML team look like? Like, what is happening behind the scenes?
We're doing science every day. There are a few topics. I set the agenda, and there are a few topics that we really care about. And we're doing science every day to try to figure out how to improve that. We only work on things where there's no known answer. Otherwise, it's engineering. And so we're constantly trying new things, pushing the envelope, testing things we've read about in the literature to see if they actually work, and when they actually work in scenarios our customers care about. That's every day for us. We're in the lab. We're trying out new ideas. We're trying to push the envelope on what's available for us and our customers.
So literally get the paper, try to implement it and see.
Or try out a new idea.
Nice.
Completely new ideas, things that we think are relevant for our customers. But, we do have to test a lot of papers because papers come out, but we don't know whether they really work in the settings we care about. Just because it's a paper, just because it's published, doesn't mean it works. It doesn't mean it works for a customer. So, we spend a lot of time thinking about that. And sometimes papers work phenomenally well. Often they don't, because we're testing them more rigorously and at larger scales than people in academia can, because we have more resources. So, sometimes we succeed, sometimes we don't. I try not to talk about the things that don't work in public because, a lot of them are written by students, and I don't have any reason to want to make a student's life difficult. I was a PhD student not too long ago. But in general, we need to test everything and have data to back up what works. You can see this in our new paper on LoRa. Everybody's talking about LoRa. Everybody on Twitter seems to love LoRa. Is LoRa really good? Just because people are talking about it and hyping it up doesn't mean it's good. And so we had to go and figure it out.
All right, don't trust Twitter.
Yeah, don't trust Twitter. Don't trust your friend of a friend at OpenAI. Don't trust a paper. Trust real data and real science.
Thank you so much, Jonathan. Thanks for all the insights. Thank you, Maria, for being here with us. I hope it was a good session and you had a good time, and I hope we'll see you soon.
This was awesome, and I can't wait to do this again soon when we have more to talk about.
Amazing.
Thank you, guys. Thank you.
Awesome. Thank you so much.